Hi, some people had some problems with this worksheet, so I'm going to go through and do all the problems with you. You can correct your worksheet while you're doing this, and you can pause the video and try and do them before I do them. The first thing to know is some problems say a condition is at STP, an initial condition, a final condition. Standard temperature is 273 K, and standard pressure is either 1 atmosphere, in atmospheres, 760 in millimeters of mercury, or 101.3 kilopascals. These are all the same. They're just different pressure units. Something else I'm noticing is people don't know what our pressure is versus volume. So pressure can be atmospheres, millimeters of mercury, or kilopascals. Okay, that's pressure, that's the force. Volume, how big is that container, can be in milliliters or liters. And our temperature is degrees C or Kelvin, and if it's in degrees C, you got to convert it. Once you fill in your initial conditions, which is 1, that's what we started at. It could be number 1, it could be initial, it could be before, whatever you want to call it. And then we fill in our final conditions. You need to make sure that your units match. Notice I changed these so they are both atmospheres. If your units aren't the same, your calculations will be wrong. Why? Because when I set up my problem, here I've rearranged the formula, then I've plugged in the appropriate P1. Remember, this would be P1V1, and this would be P2V2, because this is 1 and 2. 1 and 2. Once I plug them in, you can see that my atmospheres, because they're the same units, they cross out. I'm left with liters. Here I was solving for volume, so that was correct. Okay, so we are going to do number 1. This says the volume of the gas is in 12 liters. So that tells me what the volume is, but it doesn't always say volume. I know it's volume because it's liters. And this volume of gas and its pressure is 3 atmospheres. These happen at the same time. They are a initial or a number 1 condition, and this is volume 1, and this is pressure 1, because pressure is in atmospheres. The pressure is decreased, so now we have a new pressure. What is the new volume? Okay, so plug those in. Once you have your units plugged in, you need to make sure they match. These are both in atmospheres, so I don't have to convert. My first volume is liters, which means my answer is going to be liters. This doesn't tell me what my volume has to be in, so I'm going to keep it in liters. And now I have my formula, P1V1 N1T1 equals P2V2 N2T2. Should be a baby N. Okay? And notice number of moles aren't there and temperatures aren't there. That means they stayed the same. If they gave us a temperature that was identical for 1 and 2, they'd be crossed out as well. So I don't need these guys in this formula. So my formula is P1V1 equals P2V2, and I'm solving for volume 2, so I have to get it alone. I'm going to divide by P2, divide by P2. In my formula, my correct formula, rearranged, is P1V1 P2 equals V2. Now, on your test, this is going to be worth 2 points. This is going to be worth 1 point. Plugging in your numbers correctly, so my P1 right here, number 1, this is all number 1. My P1 is 3.0 atmospheres times my volume 1, which is 12.0 liters, divided by my P2, which is 1.5 atmospheres, equals my V2. This will be worth 1 point, and then your answer with units will be worth 1 point. Your test will be multiple choice, just like it always is. These questions will be worth 5 points. If you decide you want partial credit, you can send in a picture of your work when you finish the test, immediately then, not days later. And I will go through, and if you didn't get the answer right, you will get partial credit. You'll get 2 points just for filling in the box. Okay? Now, when we do this, our new volume was 24 liters. 3 times 12 is 36, divided by 1.5 would give us 24 liters. Okay, so our pressure, let's put 24 liters here. Our pressure was cut in half, and what did our volume do? It doubled. This is an inverse relationship. One went up and the other went down. When the pressure of the gas is increased by 3 times, how much will the volume increase or decrease? Well, we said pressure and volume was inverse. So if the gas is increased 3 times, the volume would decrease, and it would decrease by 1/3. Whose law is this? This is Boyle's law. And the graph, which it doesn't ask you about, inverse would look like that, pressure over volume. Okay? Problem number 2. We have 500 milliliters of gas collected at 74.5 kilopascals. Milliliters is volume, so that's our volume 1. And at the same time, when it's collected, it has a pressure, because kilopascals is our pressure unit, pressure 1. Okay, and that's on your cheat sheet. What are your units? What is the volume? So volume 2 at standard pressure. So our standard pressure is all listed right here. Okay, it's also listed on your cheat sheet. But there are 3 of them, and I need to know what is standard pressure in kilopascals. Well, that's 101.3 kilopascals. Okay, so this formula is exactly like this one, right? I'm solving for V2. So my correct formula rearranged would be P1 V1 P2 equals V2. And when you plug that in, when you plug all that in, you would end up with 367.7. Now my kilopascals cross out. This is milliliters, so this has to be milliliters. But it asks you to find it in liters. I could have converted this into liters first, and then my answer would be in liters, or I can convert it afterwards. There are 1,000 milliliters in 1 liter. Why did I put milliliters on the bottom? Because I started with milliliters. I get rid of the unit that I have by putting it on the bottom, and I go to the unit I want on top, and that would give me 0.368 liters. Your answer is kilopascals. That's wrong. I'm not sure what's going on there, but you needed it in liters. Problem number 6. We have 200 liters of helium at 2 atmospheres and 28 degrees C. Okay, now I can never use degrees C, so 28 plus 273 equals 301 Kelvin. Okay, so this is all happening at the same time, which means it's a number 1 condition or initial condition. As long as you keep your pairs together, it doesn't matter if you put it in 1 or 2, though, just so you know. So we have 200, oops, that's not pressure, that is volume. 200 liters. Liters are volume, that's volume 1. Atmospheres is pressure, that's pressure 1, so 2.00 atm, and 301 Kelvin. Okay, now it's placed in a new tank with an internal pressure of 600 kilopascals. and we need to find the volume of helium after it's compressed, and the temperature remains the same, 301 Kelvin. Okay, we changed our temperature to Kelvin. However, it remains the same. If it stays the same, you can put it in your formula, but it's going to cancel out and it just makes a mess. So let's get rid of it. We don't have moles. So again, we have P1 V1 equals P2 V2. Our temperature was in K, but it's gone. And my units, do they match? Well, if this is liters, I'm solving for liters. And it doesn't tell me what units I need, so I'm going to keep that liters. This is kilopascals, and this is ATM. One of them has to be changed. It doesn't matter if you make them both kilopascals or you make them both atmospheres, okay? So let's set that conversion up. 2.00 atmospheres. I do not want atmospheres anymore. I want kilopascals, and I know for every 1 atmosphere it's 101.3 kilopascals. How do you know that? It's on your cheat sheet, and these guys are all equal. Okay, so when I figure that out, that's going to give me 202.6, my atmospheres is gone, kilopascals, okay? So some of you might have gotten your number just a little different from the answer, and that is because you probably switched your kilopascals to atmospheres instead of your atmospheres to kilopascals, and that's fine. If you're within, a couple of tenths, you're good. Oops, 202.6 kilopascals. Okay, so my correct formula, I'm solving for V2. That's what we've been doing. P1 V1 divided by P2 equals V2. I plug that in, 202.6 kilopascals times my volume, which is 200 liters, divided by my final, which is 600 kilopascals. And if you plug that in, my kilopascals cross out, and you should get around 67.6 liters. Okay? Some of you might have gotten, I think, 67.5. That's just depending which way you change that, and that would be correct. Okay? And now we go on to number 7. This has a volume of 14 liters. Remember, sometimes it doesn't say volume. Liters is volume. I'm going to put volume 1. And when I have this 14 liters, it is a pressure of 1 atmosphere. Find the volume, find volume 2 of the nitrogen when the pressure is changed to 700.0 millimeters of mercury, which is my pressure 2. This was my pressure 1. Okay? So, volume, 14.0 liters. Pressure, 1 atmosphere, 1.00 atm. My new pressure is 700 millimeters of mercury. And find the volume. Question mark. Okay, so my temperature's held constant. I don't have moles. My volume's going to be in liters. Do these units match atm and millimeters of mercury? They don't. Well, I do know I don't have to convert 1 atmosphere to millimeters, because I know 1 atmosphere equals 760 millimeters of mercury. So that's the easiest, fastest way to do that. If you change this one to atmospheres, that's perfectly fine. And now we are going to write the correct formula, rearranged. We're going to plug in our numbers, which is 760 millimeters of mercury times 14 liters divided by 700 millimeters of mercury equals our V2. And here was your answer with units. Okay, so I hope going through this helped you. We are going to do these problems again. Most of these were rearranging our P1V1. Our next set of problems, you're just going to have 4, is going to be make sure you change your temperature, and we're going to be rearranging our combined gas law just a little differently so you have more practice.